Right, today we are going to discuss the chapter hydrogen chloride. This comes under study of compounds, and in this hydrogen chloride also one of the important topics. So hydrogen chloride, or we call it as hydrochloric acid, which is naturally produced in human stomach and which helps in digestion of food, and it is also called muriatic acid. Now we are going to see how we prepare hydrochloric acid, and before that we see how HCl gas, how hydrogen chloride gas is produced. The first reaction is by synthesis reaction, which is also called direct combination, in which the elements of hydrogen chloride, that is hydrogen gas and chlorine gas, undergo combination reaction, that is direct combination, to form hydrogen chloride gas. And the condition for this reaction is this reaction has to be carried out in diffused sunlight. The reason is the reaction, if it is carried out in direct sunlight, it may cause explosion, because hydrogen is highly combustible gas and the reaction is highly exothermic, so which will cause explosion when it is carried out in direct sunlight, which is not controllable. And in this, moisture can be used as a catalyst. So in this particular reaction, moisture acts as a catalyst. So this is a general preparation of HCl gas, that is hydrogen chloride gas. Then we are moving to lab method to prepare hydrochloric acid. So in this lab method, we use two reactants, that is NaCl, that is sodium chloride, which is also called rock salt, and concentrated sulfuric acid. So in this, we take a round bottom flask. In the round bottom flask, we are taking these reactants, sulfuric acid and sodium chloride. And this mixture will be heated, maintaining a temperature below 200 degrees Celsius. Temperature is maintained below 200 degrees Celsius, and we make sure that the temperature doesn't go beyond 200 degrees Celsius. And we see what is the reason for that. When you heat this mixture of these two, sodium chloride and concentrated sulfuric acid, this is a reaction which takes place below 200 degrees Celsius. So this gives sodium hydrogen sulfate as a byproduct, and this is the HCl gas produced. This HCl gas which is produced, that will be sent through a delivery tube, and then it is passed into sulfuric acid, concentrated sulfuric acid again. So here this sulfuric acid acts as a drying agent, means sulfuric acid is used to remove moisture from hydrogen chloride gas. It is used to remove moisture from hydrogen chloride gas. So what is the drying agent used here? Concentrated sulfuric acid. Concentrated sulfuric acid is used as a drying agent to remove the moisture from HCl gas. Once you remove the moisture from HCl gas, now the dry HCl gas moves this way, and here we collect dry HCl in the gas jar. Now in this gas jar, when we collect HCl gas, since HCl is heavier than air, it moves downwards, which will push the air upwards. So the method of collection of HCl gas is nothing but upward displacement of air. The method of collection of HCl gas is upward displacement of air. Because HCl is heavier than air, it will be trying to move downwards and pushing or displacing the air upwards. And HCl, since it is highly soluble in water, we cannot use downward displacement of water method. If you use water, the HCl will be absorbed in the water itself. So you cannot collect HCl gas. Now, the condition we maintained is below 200 degrees Celsius. You can produce HCl even at more than 200 degrees Celsius. But we always prefer to maintain a temperature below 200 degrees Celsius only. The reason is, it is just to save the fuel. In case if you are taking a temperature more than 200 degrees Celsius, it is just waste of fuel. And because you are going to a high temperature, it may cause breakage to the apparatus, or the run bottom flask may crack because of the high temperatures. So to avoid that, it's better to maintain low temperatures only. And apart from that, so when you take a temperature more than 200 degrees Celsius, the byproduct is sodium sulfate, so which will form a hard crust in the round bottom flask. The sodium sulfate which is formed as a byproduct, it will form a hard crust inside the round bottom flask when you take a temperature more than 100 degrees Celsius. So because of all these disadvantages, with high temperature, we just maintain the low temperature, that is less than 200 degrees Celsius. Then, precautions to be followed. The reactants must be heated slowly, means you cannot increase the temperature all of a sudden, so you need to heat the reacting mixture or the reactants slowly, so that the reaction is taking place in moderate speed. And the lower end of the thistle funnel should always be dipped in concentrated sulfuric acid. So in the diagram you can see the thistle funnel is always dipped inside the liquid. Otherwise, the HCl gas which is produced, there are chances that the HCl gas or any gas which is prepared this kind of method, that can escape through the thistle funnel. And the next one is, HCl gas is purified using sulfuric acid, but not using calcium oxide and phosphorus pentoxide. The reason is, this calcium oxide and phosphorus pentoxide, they can react with HCl to give the products like calcium chloride and PoCl3. That means they will react with HCl and they will consume HCl gas, and you will not be able to collect that HCl gas. So that's why it is necessary to use only concentrated sulfuric acid as a drying agent, because sulfuric acid just removes the moisture but does not react with HCl, or it does not consume HCl gas. And identification test for HCl gas. A glass dot dipped in ammonia solution is kept near the gas jar, which will give you dense white fumes. And these dense white fumes are of ammonium chloride. So this is the identification test for HCl gas. So very important one. So when you take a glass rod and dip it in ammonia solution, and when it is brought near the gas jar filled with HCl, it will give you dense white fumes. Right? So this is the identification test for HCl gas, and it is very important one. So this is the preparation of HCl. So once we recap, so in this the reactants what you are using are concentrated sulfuric acid and sodium chloride. So when you heat this, we maintain a temperature below 200 degrees Celsius but not above 200 degrees Celsius. If you maintain the temperature above 200 degrees Celsius, then also you will get the same product, that is HCl gas. But the thing is, when you use more than 200 degrees Celsius, the fuel is just wasted, because at lower temperature also you are getting the HCl gas. So you don't need to go for high temperatures. So just to save the fuel, we stick to the lower temperatures. And the method of collection of gas is upward displacement of air, and the drying agent what we are using is concentrated sulfuric acid, but not calcium oxide nor phosphorus pentoxide, because they can consume hydrochloric acid. Next, properties of hydrogen chloride gas. So under physical properties, mainly we discuss about the high solubility of HCl gas. HCl gas is highly soluble in water. So to show the high solubility, or to demonstrate high solubility of HCl gas, we have an experiment called fountain experiment. So in this fountain experiment, you will be taking a round bottom flask which is filled with dry HCl, and here you will take a litmus solution, and these two round bottom flask and this litmus solution are connected with a jet tube, nothing but a very thin glass tube, and here you can see a dropper filled with water. So now when you take this arrangement, okay, and you just have to squeeze the dropper so that a small amount of water enters into the round bottom flask. So when the water enters the round bottom flask, immediately it absorbs this whole HCl gas present in the round bottom flask, and which will create vacuum in the round bottom flask. So if vacuum is created in the round bottom flask, what do we see is the blue litmus solution rises through this jet tube or this thin glass tube, and it rises and comes out like a fountain in the round bottom flask. So which confirms that vacuum is created in the round bottom flask, and the vacuum is created due to the high solubility of HCl gas in water. So that results in the formation of this fountain inside the round bottom flask. And since HCl gas turns this litmus solution to red color, you will see red fountain in the round bottom flask. And this is very important to remember, that this fountain experiment is to prove high solubility of HCl. It is to prove high solubility of HCl, but it is not to prove acidic nature. So most of the people, students, they make a mistake here. The importance or the purpose of fountain experiment is to prove the high solubility. Remember this. It is to prove the high solubility of HCl gas, not to prove its acidic property. Next, coming to the chemical properties. One, HCl is non-combustible, and the second one is HCl gas can undergo reversible thermal decomposition. So which is also called thermal dissociation, reversible thermal decomposition or thermal dissociation. Okay, so here it is reversible reaction. When you heat HCl over 500 degrees Celsius, it will decompose to give hydrogen gas and chlorine gas. And similarly, when ammonia reacts with HCl, it will form ammonium chloride, so which will give you dense white fumes. So HCl and ammonia will react with each other, both the gases, and they will give you dense white fumes of ammonium chloride. So this is the reaction. Then HCl gas can react with active metals like iron, zinc, magnesium, and since these active metals are more reactive than hydrogen, those metals can replace hydrogen from HCl, so that hydrogen gas will be produced in all these cases. So this is one of the preparations of hydrogen gas. Next, preparation of hydrochloric acid. So till now we have seen the preparation of HCl gas and the properties of HCl gas. But now we are going to talk about hydrochloric acid. Hydrochloric acid is nothing but hydrogen chloride gas is dissolved in water. When you dissolve hydrogen chloride gas in water, it produces hydrochloric acid, or the resultant solution which we obtain by dissolving HCl gas, hydrogen chloride gas in water, is called hydrochloric acid. Then for the preparation of hydrochloric acid, so direct absorption of HCl gas in water will cause back suction. Okay, so this back suction will oppose the process of dissolving HCl gas in water. So that is a disadvantage with this back suction. When you try to dissolve HCl directly, or direct absorption of HCl in water will cause that back suction. So to overcome this problem, to overcome this issue of back suction, we use a funnel arrangement or a special funnel arrangement. So in that, so the arrangement will be like this. So this is water, and from here you are sending HCl gas, and this funnel is attached here such that it will be just above the surface of water level. Now when HCl gas comes into the delivery tube and it enters the funnel, and the HCl gas will be absorbed by the water in the beaker. When HCl gas is absorbed by the water, so even this causes a partial vacuum in the funnel, which will suck the water backwards into this funnel. So because the HCl gas is absorbed by water, it will create a partial vacuum in the funnel, and that will suck the water backwards. So when the water gets into the funnel, the water level in the beaker or the trough will fall down. At the same time, due to the gravity, again the water in the funnel will fall back into the beaker. So in this way, the process will be repeated until you get a required concentration of HCl. Okay, so HCl is dissolved into the water, and water will be sucked up into the funnel, and then the water drops, and that will stabilize it by the air. Then again the HCl is absorbed by the water, and again it takes the water into the funnel and it falls due to the gravity. So the process will repeat until you get required concentration of HCl in the beaker or the trough which is placed below. So here the funnel arrangement is mainly to prevent back suction or to reduce the back suction, and it also gives, because the funnel has a broad mouth, it will give you larger surface area for the absorption of HCl in water. Next one, HCl is dissolved in water, it will ionize to give H plus ions and Cl minus ions. And this H plus ion combines with water to form hydronium ion. So the resultant equation is given here. So HCl when dissolved in water gives H3O plus Cl minus. And the reactions of dilute HCl. So just like HCl gas, dilute HCl also can react with active metals to produce hydrogen gas, because active metals are more reactive than hydrogen. So those active metals will displace hydrogen from the HCl gas. And hydrochloric acid is an acid, so acids usually react with bases to form salt and water. So these are the examples here. When sodium chloride reacts with NaOH, it forms sodium chloride and water. And when HCl reacts with copper oxide, it forms copper chloride CuCl2 and H2O. Then another common reaction of dilute acids is with metal carbonates. When dilute acids react with metal carbonates or bicarbonates, they produce salt, water and carbon dioxide. Now, example is given here. When HCl reacts with sodium carbonate, it gives sodium chloride salt, water and carbon dioxide gas. And what you have to remember here is, this carbonate whenever reacts with HCl, it gives carbon dioxide gas. Carbonate always gives carbon dioxide when reacts with HCl gas. Similarly, with metal sulfides or bisulfides, dilute HCl reacts with sodium bisulfite to give salt, water and sulfur dioxide. Like carbonates give carbon dioxide, here sulfides will give sulfur dioxide. Next one, metal sulfide with dilute HCl will give you H2S gas, which has a Rottenac smell. Example, dilute HCl when reacts with copper sulfide gives copper chloride and H2S gas. Similarly with FeS, that is ferrous sulfide, HCl plus FeS will give you FeCl2 and H2S gas. So carbonate gives carbon dioxide, sulfite gives sulfur dioxide and sulfide will give you hydrogen sulfide gas. And apart from that, HCl when reacts with silver nitrate solution, it gives silver chloride white precipitate. And this white precipitate is soluble in excess ammonium hydroxide solution. And when HCl reacts with lead nitrate, it gives white precipitate of lead chloride, which will dissolve on heating, because lead chloride is insoluble in cold water but soluble in hot water. So these are the reactions of, anyhow the 8th reaction is out of portion. So those are the 7 important reactions with dilute HCl. Then the reactions of concentrated HCl. So concentrated HCl can be oxidized easily using oxidizing agents like manganese dioxide, potassium permanganate, dichromate, lead dioxide and lead tetroxide. So in all these cases, the common product is chlorine gas. So in all these cases, one observation what we can write is, greenish yellow gas is produced. Greenish yellow gas is produced in all these cases. Means whenever you reduce concentrated HCl using any oxidizing agent. Sorry, whenever you oxidize concentrated HCl using any oxidizing agent, common product is chlorine gas. So common observation will remain as greenish yellow gas. These are the chemical reactions of HCl. Okay, so from here mainly the preparation of HCl, fountain experiment, then funnel arrangement and the reactions of HCl. These set of reactions are enough if you prepare. So in all these reactions you will get observations. For hydrogen the observation is a colorless gas which burns with blue flame, and carbonate gives carbon dioxide. Observation for this will be brisk effervescence which turns lime water milky but has no effect on potassium permanganate. Then dilute HCl with sulfite will give you sulfur dioxide, and observation for sulfur dioxide is suffocating gas which turns lime water milky and decolorizes potassium permanganate. And with hydrogen sulfide or metal sulfide will give you hydrogen sulfide gas, and hydrogen sulfide gas has a rotten smell. And with silver nitrate it gives white precipitate which is soluble in excess ammonium hydroxide, and with lead nitrate it gives white precipitate of lead chloride which dissolves on heating. Then finally the oxidation of concentrated HCl with any oxidizing agent. These are the oxidizing agents: potassium permanganate, manganese dioxide, potassium dichromate, lead oxides. These are oxidizing agents. So they will oxidize concentrated HCl and they will produce chlorine gas. So here the observation will be greenish yellow gas. Greenish yellow gas, that is chlorine gas, will be the observation in this case. So this is about HCl.